and understand how memory is accessed. Okay, so this example here will be pointer review. And this would be 2.c. Okay, so again, let me just copy this part here. And we're going to save this as a .c file. And just paste that one here as pointer review 2. Okay. And I'm going to leave some space there for the functions that we're going to need. I'm going to declare them or define them before main. So first, let's make sure we have the appropriate library to do some printfs. Okay, let's get to the bottom here and do an int main and system pause. So we can actually hold the screen and then return 0. Okay, so again, compile and run at this stage just in case. All right, that automatically saves it, by the way. Press any key to continue. I'm going to be saving a lot as I progress because this compiler has a tendency to freeze once in a while, and then we'll lose our work if we type too much stuff. So it's always a good idea to save your work, compile, and so on. Save first before you compile, just in case it freezes in the middle of that, and you have tons of code that you didn't save. You're going to have to literally kill the process and come back, and you will have a lot of lines of code that will have disappeared. So let's start with the same example. So let's say we had int data, and let's say we give it a value of 0. So this is now what we call an initialization, right? So we declare and assign a value. Other way, so you could printf the value of data, or the initialized, if you want to be, the initialized value of data equals, and that would be %d/n and data, right? So this is what we started with. Let's go ahead and compile and print. So first, let me save. Okay, and you can see that we're getting 0. So now, let's pass this to a couple functions. So we're going to have a function where we're going to pass by value and see what happens to data. And same thing here, we're going to have another function where we're going to pass by reference. And again, we'll see what effect that has on data, since we're going to pass data as a parameter. Okay, so this function here, let's call it pass1. And it will take an integer as a parameter. Let's call it copy. And that's indeed what it will be. It will be a copy of your data. Right, so let me save that for now, even though it's gutted. There's nothing going on in here. We're going to be calling pass1, right? So pass1, and we're going to pass data to it. That's the point. So we want to see what effect does that have on data when we come back to main. So when you call a function, you're going to leave the main, right? You're going to execute what pass1 has as code, and then you're going to come back where you left off. Okay, so somewhere right here, maybe it's a good idea to printf and the value of data after calling pass1. We want to know what it is, equals %d/n and data. Okay, we want to know what happened to it. So first, I want to print copy within pass1. Again, let me save. So sure, so we could do a printf. The value of the local variable copy equals, that's the variable. Copy has been declared in pass1. It is still considered a local variable to pass1. Get to the function pass1. Okay. %d/n, and that would be copy. Okay. So let's see what that does for us. So compile and run. Okay. So as you can see, 0, 0, 0, 0, right? So nothing happened to data. So let's try to alter data indirectly via this function and see if indeed, by passing by value, will it alter data when we come back? So let's make copy equal -8. Let's see what happens, right? My prediction, and if you were diligent to read your textbook about how C works, when we come back, data is going to be still 0 in main, right? So that's because copy and data are at two different memory locations. They're not related. You just passed a value, a copy to copy, right? That's why I call it copy, right? So let's go ahead and copy, and sure enough, that 8 had no effect whatsoever, right? Just to prove the point, we can printf that copy indeed changed after altering it equals %d/n copy. But when you come back to main, it had no effect whatsoever. So compile and run again. And sure enough, you get your -8 within the function pass1. But when you come back to main, data is still 0. Okay? Good. So what's the advantage of doing something like that? If you want to pass a copy to a function, let it handle it, do its own thing without affecting data, then this is a good strategy. You pass by value.